Page 12. It says mark 2 to the first, 2 to the third, 2 to the fourth on the number line. It says 2 to the second and 2 to the fifth are already marked for you. So this one on the end must be 2 to the fifth. 5 must have got cut off there. All right, so let's talk about 2 to the first. Where do you think that should go?
In between the 0 and the 2.
Absolutely, in between 0 and 2 to the second. Remember, 2 to the second is 4. That's why it's 4 spots away. 2 to the first is just 2. How about 2 to the third?
3 spots away. So it would be in the fifth one. So
Here?
no.
Here?
No.
Here?
Yeah.
No.
No. Keep on going 3 more spots, and it'll be good.
Well, what's 2 to the third?
6.
No.
2 to 6.
No.
5.
What's 2 to the third, guys?
3
2 to the
times
fifth.
1.
2 to the third.
2.
Bless you.
That was disgusting.
2 times itself.
That was very disgusting.
The number.
We don't know 2 to the third. 2 times 2 times 2. We can do that.
Oh, it's 6.
It is not, Landon. Remember when we talked about the most common mistake is taking 2 times 3, which is what you were doing.
2 times 9? 8.
8. 2 times 2 is 4, times 2 again. 1, 2, 3, 4, 5, 6, 7, 8. Okay, 2 to the fourth.
It's skip 1.
What's 2 to the fourth?
2 to the 4.
You just told me 2 to the third, another 2.
Oh, 2 to the not 10th.
What was 2 to the third, guys? You just told me that.
8.
What's times 2 again?
16.
Thank you. All right, the values are not the same distance apart. Find a precise way to describe how they are placed. How are they placed? Well, this distance is 2. This distance is 2. This distance is 4. This distance is 8. This distance is 16. So what is happening to the distance?
It's times itself.
It's doubling.
Doubling.
Yeah. I would say it's doubling. Probably you might say, well, the first one didn't double. Well, technically I would say this is where we're starting at. 2 to the first. So probably wouldn't even include that one on there. Okay, for power of 2, when the exponent increases by 1, the value doubles. Okay, 2 to the third, he told me was 8. I increase the exponent by 1 to go to 2 to the fourth, and you notice that it doubles. How if I go the other way? If I go from 4 to 3, what happens to my actual value?
Decreases.
So if I go this way, it doubles. If I go this way, it is... What's the opposite of doubling?
Subtracting.
Dividing.
By?
2.
Yeah, half.
What is that?
Half is big, going by half.
Is that G-O?
Here,
Yeah, what's that one?
going
Oh.
by a half. Dividing by 2, half as much. All right, so knowing that, what is half of 2 to the 50th? Use an exponent.
25.
43.
2 to the 25th.
You just told me what happens if I decrease the exponent by 1. You just told me it's half as big. So if I want to know half of this number,
100.
I decrease the exponent by 1. All right, 1 less 2. 1 less times 2, the answer is 49. 2 to the 50th, half of it would be 2 to the 49. What is half of 2 to the 100th?
99.
2 to the 99. 1 less times 2. All right, 2 to the first is half of blank.
0.
2 to the first is half of blank.
Second.
2 to the second. 2 to the 0 is half of 2 to the first. 2 to the negative 1 is half of 2 to the 0. 2 to the blank is half of 2 to the negative 1.
-2.
1 less exponent. Good. All right, let's put them on a number line. We'll just follow along. Here's 2 to the second, which is 4. So 2 to the first would be halfway.
2 and 2.
2 to the 0 would be halfway.
-1.
2 to the negative 1 would be halfway.
-2.
2 to the negative 2 would be halfway. So they're all half. Decreasing by exponent by 1, half as big. Adding 1 to the exponent, twice as big. All right, question 7. Start here and work down. Two to the fifth. 2 times 2 5 times is 32. 2 to the fourth is 16. 2 to the third is?
8.
2 to the second is?
4.
2 to the first is?
2.
2 to,
No, half.
2 to the 0 is?
2. Halfway. 2 negative
0.
2. 2 and 1. 2 and
Half of
negative
32, 16.
1.
Half of 16, 8. Half of 8, 4. Half of 4, 2. Half of 2,
1.
1. Half of a 1,
Negative 1.
0.
half of 1.
Half.
We have $1, we're going to split it.
50.
50 cents.
Half, 50 cents. Half of a half.
1/4. 1/3.
Half of 1/4 is 1/8. Half of 1/8.
1/16.
Half of 1/16.
1/32.
Yes.
That was easy.
All right, one thing I want to point out. Anything to the 0 power is 1. So no matter what number it is, if it's got a little 0 there, your answer is always 1. Landon, that would have been an important thing to write down. All right, question 8. I would like you to try that one. It says 2 to the third and 8 are all the same number. Circle all the ones there that you think equal 8. I'll give you a minute or so, maybe a couple. Circle all the ones where the answer is 8.
How many are there? I have like 4.
4?
4. I have 4 too.
You only have 4?
I have 6.
Is there more than 4?
I don't know.
I have 6.
Well, what's 2 times 4?
8.
How about 8 times 1?
8.
2 squared, that's 4, times 2.
8.
4 times 1 times 2.
I swear if they're all circles.
2 to the 0, I just told you anything to 0 is 1,
Yep.
times 2 to the third.
8.
1 times 8 is 8.
Wait, how'd you get? Huh?
Anything to the 0 power is 1. So this is like there's a 1 there.
Yeah.
2 to the third is 8. 2 times 2 times 2 is 8.
Oh. Now I get it.
I have 6 circles.
F.
All ones that circle.
Remember a little rule. You can add these two things together.
Yep.
What's 6 minus 3?
3.
So is 2 to the third 8? Yes.
Oh my goodness.
They're all circles.
What's half of 16?
8. Yep, I'm done.
64 divided by 8.
8.
They're all circles.
Are all of them 8?
I don't know.
Most likely.
2 plus 5.
8.
2 plus 5.
That's 7, by the way, Maddie.
2 plus 5 is 7. Minus 4.
1.
It equals 8.
3. 2 to the third. 8.
8.
Bro,
They're all 8.
I got
0 plus 4 minus 1.
8.
No.
It equals
3, which is 8.
Oh my goodness.
Half of 16, 8. 32 divided by 4, 8. It should have been all of them. Yes.
What?
I only had 6 circles, so technically I was closer than everybody here. So.
Hey.
So that'd be a 50%.
You got 50%.
All right, it says 2 to the negative 1
7, 8.
and a half are the same number. Write 3 expressions using powers of 2 that also equal a half. All right, I'll give you one. I just need to somehow to get to negative 1. So I'm going to say 2 to the 5th.
You just gave us 1. That's 1 right there.
No, it says it in the problem. 2 to the 5th. 2 to the 1st. That's a total of 6. I need to get to minus 1. So I'm going to have a negative 7. So there's 1.
Oh, but what I'm trying to say is remember
Okay, get other,
gave us 1.
get other 2, please.
Oh, 1.
Could you just go?
Get 2 more, please.
Literally just write down what's up above.
Could you do 2 negative 1? Wouldn't that just work as that?
Well, I mean, it already gave you that.
So we can't.
I mean, if you're going to do that, then you got to do something like that.
Okay.
Anybody else got one?
No.
Since we already did 2.
We did?
Infinite number of possibilities here.
I did 3.
What do you got for your last one?
2 to the 10th and 2 to the 11th.
Perfect.
So what were these questions about? Oh.
All right. Question 10. Powers of 3. Just like we did the powers of 2, why don't you see if you can do 10 and 11?
Okay.
Now notice it's not half like it was with 2. Look at the pattern.
I do see the pattern. Got it.
Really?
Yeah, that was pretty good. Mr. Milburn, we need harder ones next time.
All right, tough guy. See what you got then. You want 10 or 11?
Can I do
I'll do I'll do 11.
Okay.
I'm gonna do 10.
I want to do 10.
5, 1 over 5, 1 over 25, 1 over 125.
That's good.
And then 10.
Nope.
Me.
Kira, go ahead.
And 3, 1, 1 over 3,
No, I'm just kidding.
1 over 9.
Good. All right, can you get
Maybe.
Already done?
the last one?
I can do it.
Go ahead.
X1
Yeah, or just X, don't need the 1.
or
Okay.
and then X2
Nope.
1 over X2.
Nope.
No.
Yeah.
No, it's not.
Brandon.
But it's just X.
Nope.
Just 1?
2.
Just 1. Anything to 0 power, remember, is 1. See? All the same.
And then now it's
1 over X.
1 over X2, and
Brandon.
squared, and 1 over X3.
Okay, so negative exponent just basically means it's going to be a fraction.
Wait, what happened?
It was
to the
super
negative?
easy.
Is it not negative?
Well, these weren't negative.
The one in the X.
These weren't negative.
Didn't even notice that.
All right, so I'm going to show you a pattern here. Landon, pay attention. This is important.
I am paying hardcore attention.
7 to the 6. So 7 times 7, 6 times, it gives me this number.
That's huge.
It wants to know 7 to the negative 6. So that is the same as 1 over that number. So all a negative exponent does is bring it to the denominator. Landon, 14. What is 17 to the 0 power?
Just 1.
1, good. Anything to the 0 power is 1.
And then the next one
Nope.
is just 1 over...
So 17 to the negative 1
1 over 17.
is 1 over 17. Good.
Try, but I'm
Negative exponent goes
What?
to the denominator.
just kidding.
Question 16. Carla and Jacob are debating their strategies for answering 5 to the 3 times 5 to the negative 2 equals?
2. Not.
Equals what? Let's fill in
1.
that blank.
1.
Well, 5 to the 1, yes. And again, you can have the 1 there, it's not really required. Carla says negative exponents are fractions. So we can write 5 times 5 times 5 times 1 over 5 times 1 over 5. Okay, let's look at that one first. That's fine. Okay, 3 5s, 2 of them with the denominator. Notice if I would cross cancel a couple of them, what you'd be left with. So Carla's not wrong. Jacob says negative exponents mean division. So we can write 5 times 5 times 5 divided by 5 divided by 5. Well, 5 times 5 times 5 is 125. Divided by 5 is 25. And then divided by 5 again is 5. So they are both correct. I don't think either one said the easiest part, that if you have the same big number, the same base, you just add the exponents. 3 minus 2. Michael says, can we come up with a way to explain 5 to the 0 power? He says, I know it's 1, but every time I see it, I still think it's 0. Okay, so how do we know that 5 to the 0 power is 1? Well, again, you could just show a pattern here. 5 to the 0 is, or 5 to the squared is 25. 5 to the first is 5. 5 to the 0 is 1. 5 to the negative 1 is
1 over 5.
okay, and again, you can see the pattern. Divided by 5. Divided by 5. Divided by 5. And I can keep going. So all the patterns are the same. All right, page 14. Let's do a couple here, and then I'll have you try some. Let's look at 17 through 29. Let's pick a couple there.
Let's do.
Devin, pick one.
20.
20. 5 to the 4th, 5 to the 7th, 5 to the -1 equals 5 to the what?
10.
10, good. 4 plus 7 minus 1. Pick one, Kira.
22.
22.
Like, that was easy.
C to the 6. C to the -10.
1.
C to the 5.
C1.
C1. 6 plus 5 is 11 minus 10.
You're right. I do see
One more. Maddie? Maybe a 27, 28, or 29.
17.
Or 17.
4 to the 7.
Yes. All right. I want you to try the other ones then. 17 through 29.
29?
29 is pretty easy,
Yep.
actually.
I'm surprised you guys didn't say one of the 27, 28, or
I thought we
29.
were just doing those 6.
Nope.
Oh my goodness, Kira!
Try the rest.
Why would you do that?
Give you 2 minutes.
Shut up. I have a question,
Just try them.
but it's a serious question.
You sure it's serious? Like you and Kyle?
Landon. I'll just guess. Last time someone guessed, they messed up.
Do we have to do 30?
I think my directions were pretty clear.
I don't remember.
Do 29.
229. Okay.
Good?
Yeah.
I just have 2 more.
All right, well, let's try it. I want to give you some time to work too. 18, Landon, you have that one?
Yeah, 18. Yeah, I have one.
What'd you get?
3 and 1.
3 to the 1st. So again, you would not need the 1. 19, Devin? M3. 21, Maddie?
6 to the 5th.
Good. Don't forget that this is a 1 right there. Kira?
Yeah.
23.
-6.
-6. Landon, 24.
Where's 24 at? Oh, got it. 10B10.
No.
I don't know how this works.
Well, 10 plus 8 is
Oh,
an add
you
2.
just don't count it in. Okay, it'll just be 10 and 10.
You just said that.
I said 10
Maddie.
B10.
-6.
-6.
Oh, I was close.
8 minus 6 is how you get the 2. Kira,
Yeah.
25.
15.
Closer than you. She got it right and you got it wrong twice by saying the same number.
I got it more than her.
Devin,
I listened to my homework.
26.
4.
What's that?
-4.
Good. All right. Write at least 3 expressions. Again, lots of choices here. Looks like I have 3 tens. And then I would have 1, 2, 3, 4 with dividing. So that would be -4. There's expression 1. Expression 2, I could combine those and just say it's 10 to the -1. Or 1/10, I guess, would be fine too. That would technically probably be 2 and 3. So other ways to get -1. How about 5 and -6? That would equal -1. Give me at least 3 expressions that would equal 9 to the 0.
10 to the 3 multiplied by 10 by the 4. 10 to the -1 or 1/10.
Okay, hold on now.
Or
Is this all 1?
I'm reading the wrong one.
Okay, I'm gonna say that sounds like the last one. Try again.
9 to the second and 9 to the -2.
Perfect. 9 to the second times 9 to the -2.
And 9 to the 8th and 9 to the -8.
Sure. How old is this one?
1.
Yeah, actually that one's good. So
29. Go ahead.
on our homework, can we just put 1 as one of the equations
If it's like this,
with the 0?
if it's anything to the 0, that'd be fine. I mean, technically, I could do 50 divided by 50 then too, because that would equal 1. I mean, a lot of different options.
After this, can we do
29.
stuff? Kier had trouble.
29.
Hey, you struggle.
Landon, you got one for 29?
Yeah.
What do you got?
This would be a good time for Kier to answer.
Wow.
Landon didn't do it.
I didn't get this one.
Maybe we should pay a little better attention, Landon.
I paid attention just
I didn't
then.
have enough time.
You can't do 9 minus 7 or 9 and 7 there.
Well, yeah,
We're
I was
dividing.
gonna do that. It's just
You're dividing.
63.
Okay, so look what happens when we multiply. What did we do to the exponents? How did we get 7?
We added.
How did we get -1 here? Added the exponents.
2.
Okay, so if you're dividing, what do you think you do?
2.
Instead of adding, you subtract. So 9 minus 7 is 2.
Got it.
So I need answers that'll give me 5 squared. Well, I can do 5 to the 3 divided by 5 to the 1. 3 minus 1. I could do 5, 1 times 5, 1. I could just say it's 25. I mean, there's a lot of different options. Got to be a little creative, Landon. All right, 30, Landon, go ahead.
Oh my goodness. Eva, Emilia, John, Demaine, and Asher have tickets for the school play. They will use all the seats in the row. RR seats 101 and 105. Eva is sitting 2 seats.
All right, so here, wait. These 5 people are sitting in a row. 5 seats.
Catherine seating.
Sure.
Eva is sitting 2 seats away from Emilia. Emilia is sitting 3 seats away from Asher. Asher is not sitting in an N seat. John is sitting in seat 105. So who is sitting next to Dominion?
Hoo-ha.
The minion.
Yeah, it's Imani, I think. There's no A at the end of that.
I think that's Damien.
Unless it's invisible. All right, who is sitting next to Damani?
It's Damani.
It's Damien. But yeah, John is in seat 5, right? So Asher is not sitting in an N seat, so we know this is not Asher.
Is that Manny or Amine?
Imani is 3 seats away from Asher. So where does Imani and Asher have to be 3 seats away from each other?
104. Or
Either 102 or 104.
That's only 2 seats away.
Asher has to be at
Asher has to be at 104 because they got to be 3 seats apart, and this one is not Asher. So this has to be Amani. Asher is here. So where is Eva? Where is Damien?
Damien is right by
Eva-
Amini.
Eva is sitting at 1 and 3.
Eva is 2 seats away from Amani. So that means Damien is here. Now the question was asking, who's sitting next to Damien?
Imani and Eva.
Eva and Amini.
Imani. That's better than Aminia or whatever you said the first time.
Or Dominion.
Or Dominion. All right, we're going to do the last one here. 31 is going to be the last one we're going to look at.
Go. 2E.
Actually,
I think we should do 32. 32 looks a little bit easier.
Landon, just stop talking. Okay, all A's here. It doesn't give us any gimmies. Unfortunately. Let's talk about things that will give us 1. Okay, so they have to have the opposite exponents to give us 1. So that means it would have to be a to the negative 1 and a to the first, or just a. So that's going to have to go on the bottom right there somewhere. The only way to get a to the first would be 2 minus 1. So a squared and a to the negative 1 would have to go down there somewhere. So I guess that gives us a clue that this has to be a to the negative 1. Because one of those has to be a to the negative 1. And this would be a to the first, or just a.
Actually.
All right, a to the 5th would be 3 and 2. Again, I don't know where those go yet. A to the 4th, exponents add up to 4. What exponents add up to 4?
A2 and A2.
Yeah, that can't be the same though. They'd be next to each other.
What about A3 and A?
A3 and A.
Wait, I had that. Why did I erase that?
Okay, so I guess that tells us where A3 has to go here.
At the bottom.
At the bottom.
A3 has to go on the bottom. A2 on top. All right, multiply together, give us 3. A3.
A3 and A.
No, that'd be A4.
Oh, A2 and A.
A2 and A. So that tells us where A has to go here then.
To the right.
And even down here, we know where A squared goes then. Where does it?
To the right.
Yeah, because A squared is going to have to go here. All right, top right, multiply to give you 6. So exponents add up to 6.
2, 3, 8.
So 3, 2, 1. Well, you should know where the A has to go.
At the very corner, far end in the middle.
So we should know it goes here.
So that means that A squared would have to go on top of that 8 with the A3.
Yeah, we don't know that yet.
A negative 1 goes in that.
This would have to be A to the negative 1. All right, multiply together to give you A.
A2.
3 things though.
A2 and 3.
I think these two are probably going to have to be the same. So I'm going to go A to the negative 1. What's negative 1 and negative 1?
2.
Negative 2 plus 3 gives you 1, so this would have to be a 3. All right, that should tell us where A3 goes here then.
At the very top corner.
And then this just filling in the missing pieces.
Those remind me of ramen packets.
Good.
The soy sauce one, you got the beef one.
What?
Good old ramen getting brought into informal algebra. I like it.
Now you know how that happened.
All right, take a look at your homework then, page 15. Should be pretty self-explanatory. Okay, A and B talk about common mistakes. Check it out. Question E, a little hint on that one. They are all not circled on that one, Maddie. I thought you'd appreciate that. They are all not circled.
I